Welcome to lesson number 5, where we're going to be looking at multiplication of rational expressions. So I'm going to start with class example number 1 here, where we're multiplying 7/10 by 1/5. So remember, when we're multiplying fractions, we don't need to find a common denominator. So I can multiply straight across. So 7 times 1 and 10 times 5 leave me with 7 over 50th. Or sorry, 7 over 50. And if we can reduce, then we should reduce, but if not, then we'll just leave it as is. Now, with 9/10 times 5/6, we can multiply straight across, or we can find common factors. And so between 9 and 6, we have a common factor of 3, where 3 goes into 9 3 times and goes into 6 2 times. And between 5 and 10, we have 1 and 2. So what we're multiplying is 3 and 1, which would give us 3, and 2 and 2, which would give us 4. Now, if we don't do this, we're going to end up with 3/4 anyways, but we would have to reduce that. And so 9 times 5 would be 45. 10 times 6 would be 6. So we had 45 over 60, which we could reduce to 3/4. So this method we can use to multiply rational numbers that contain variables. And if I have 12xy over 4z times 3xz squared over y, then the way we would do that is by looking for the common factors. And so if I were to factor out the y, I could cancel out this y here. I could cancel out one of my z's with this z on the bottom. 4 goes into 12 3 times, and goes into 4 once. And then what I'm left with is 3x times 3xz, which would result in 3 times 3 is 9, x times x is x squared, and z. In class example number 3, I have x plus 1 over x minus 2x plus 3 times 2x plus 3 over x times x plus 1. Now remember, we need to cancel out, when we cancel things out, we can cancel out factors. We can't cancel out terms. Up above, we were canceling out factors, not entire terms. And we're going to do the same thing here. So x plus 1, I can cancel x plus 1 on the bottom, and x plus 3, I can cancel x plus 3 on the top. This will leave me with 2 over x times x minus 2. We want to now state the restrictions on the variable. So all of these now are going to be restrictions on our variable. So x can't equal, so if I look at the factors I've canceled out, x can't equal -3, it can't equal -1, it can't equal 0, and it also can't equal +2. Same thing here. Now, this question is a little bit different because now it's not already factored for us. So we have to begin by factoring this expression. And so if I factor this 4x plus 16, it's going to become 4x plus 4 over, I can factor the 7 out of here, 7 2x minus 1 times 2x minus 1 x plus 4, x plus 4. Now I can simplify. Well, I can cancel an x plus 4 and one of those x plus 4s and my 2x plus 1 and this 2x plus 1. This will leave me with 4 over 7 times x plus 4, and x cannot equal -4 from here. From here, or this +1/2. With class example number 4, it's not all that different from the previous example. It just becomes something we have to factor again. And so if I look at each of these individual binomials and this one trinomial, I gotta begin by factoring them. So 2m cubed and 4m squared are both divisible by 2m squared. So I'll factor out 2m squared, leaving me with m minus 2m. Or sorry, m minus 2. On the bottom, I can factor out 3m, leave me with 3m, m minus 3. And over on this side, I can factor by inspection. So what multiplies give me negative 6 and negative 1, and adds to give me negative 1. I would have m minus 3, m plus 2. And then down here, I have m minus 2, difference of squares, m plus 2. And now we can cancel out factors and solve. So first of all, I have m minus 2 here, and m minus 2 here, m plus 2, m plus 2, m minus 3, and m minus 3. And this m and one of those m's will cancel out, leaving me with 2m over 3. And my non-permissible values are m cannot equal negative 2, positive 2, and positive 3. And also 0.